Okay, so on this episode, we bring in the president of American Wire Group, Joshua Dorfman, and one of his super smart engineers, Neal Hamer, to talk about what American Wire Group is doing here at RE Plus this year. I find the technology required to make sure that this component can talk to this component, whether you're talking about residential solar or utility scale energy, is just incredibly fascinating.
Yeah. And they're, especially American Wire Group, are sort of have a hand in every single one of those pots, because they're not just doing project development for utility scale, but the wiring and the power electronics for utility scale, for resi, getting it not just from the solar plant to the transformer, but from the transformer to the substation, right? Like making sure all of those things are talking to each other in the right ways, and building on the right timelines is a very difficult problem to solve, but they're solving it.
Yeah, I had no idea. Josh got into a little bit about how building the components that American Wire Group builds have to be sourced sometimes in the U.S., sometimes sourced outside of the U.S., and the regulatory sort of certification that goes into all of that, I found fascinating. So not only can our listeners sort of learn about their products and about what their company's doing, they've been around for a long time, but some of the challenges that the industry faces at the same time. Yeah,
right. From the manufacturing to supply chain to, just how to build our energy systems in a better way, in a more granular way, in a data-driven way. They're doing a great job of it.
I want to welcome you, Joshua and Neal. Thank you so much for being here from American Wire Group. Your second recording here at RE Plus for the Good Energy team. And we're just so glad to have you here. And we want to talk a little bit about your company. So maybe let's start with having you introduce yourselves. Tell us a little bit about how you founded your company and how it's evolved over the last 10 to 20 years.
Sure.
Actually, how long have you been in business?
AWG is 25 years old. And first and foremost, thank you for having me here. We're thrilled to be here. This is, I think, my 16th RE Plus / SPI sequence in this industry.
Yeah, and I think that's a new record for today.
I was going to say, I don't think I've heard of 16 years. We heard in 11 years earlier, but
it's really been amazing watching this industry grow. And AWG is my family business. Actually, my grandfather had a cable distribution company that my father sold in the 90s. And in 2001, my dad had a opportunity to leave that organization and start American Wire Group with a focus on the electric utility market as well as the renewable energy business. And AWG was born. So at that time, I was in college and not working in the business. And my dad and brother were running the company. And they'd say, Josh, can you help me, for a couple of days? And I'd take time off my full-time job and come down and work in the business. And what I really found and loved about this company was we have such a wonderful entrepreneurial spirit, an amazing set of customers, and we really serve an incredible mission of empowering a better world. And that's how we've kind of defined ourselves now. We directly serve the 3,500 electric utilities in the marketplace, as well as the, say, 1,000 or so EPCs, developers, and contractors that serve the renewable energy industry. And what we have built over that time is the leading brand of wiring cable for T&D applications, for renewable energy, as well as industrial applications for the low, medium, and high voltage needs.
Can you make that real for us? Make that real for an audience that doesn't know, that isn't in the weeds on how the industry infrastructure works.
Sure.
What does that look like?
So on a solar plant, that would be all of the string level wiring. So from your module to the combiners, and then from the combiner out to the inverter is your DC cabling. So commonly those sizes are 500 kc mil, 600 kc mil, 750 kc mil. These are the main trunks that move the DC energy across the solar field. And then after the inverter, it's stepped up to the transformer. The transformer moves the energy out from the transformer to the substation at 35 kV. And so across those different segments of the solar system, we have built recognized and wonderful branded products such as SunGuard for our solar system, solar DC system, excuse me, as well as PowerGuard for our AC cabling system. And as the business has continued to grow, our customers who have relied on AWG's depth of inventory and technical experience had started to say, you guys are so wonderful in the cable business. Can you start helping us with other components?
Mm-hmm.
And so as our relationships grew and our business continued to grow, we expanded into cable accessories. And for the past, I'll say 7 to 8 years, we've also been a leading supplier of power electronics, such as transformers, both the pad mount, main power transformers, as well as on the utility side, pole mount transformers. And so here with me today is Neal Hamer, and Neal is our Director of Power Engineering for AWG, who has an incredible depth of experience in the technical side of our business, as well as being a veteran in the industry like me as well.
Glad you're here.
Yeah, if I just maybe introduce myself real quick. So yeah, like Josh said, I've recently joined AWG. I actually just joined in April. My background, I started, electrical engineering in college, did 5 years at GE, and then transitioned to Invenergy, who I think, many people are aware of Invenergy, a very, very big developer, owner, operator of renewable energy. So that's really where I got my background, where I got, into the weeds a little bit with the electrical equipment. And, again, I knew Josh from the past, just working together. And when I talked to him, he sold me on the vision, again, of AWG really, wanting to be the one-stop shop, right? The solution for, you can get everything from your DC system all the way back through your substation. And, when we start getting into the infrastructure and all that, I think, that's a huge benefit to customers. And, for, someone like me navigating the troubles of O&M, equipment availability, just, accessibility, these are things that are great, very important. So it just, seemed like a good fit, and just really happy to help, AWG keep building this, transmission distribution equipment and, expanding our support. So,
awesome. So AWG does it gets the power from the panel into people's homes, the lines themselves. But I'm curious, you walked through the process, right? Like after the panel, here's the line, the wiring that goes into it. It goes into the inverter, and then goes to the transformer, and then to the substation. Can you explain a little bit for somebody, like a lay audience person, why do we need to do that? Why isn't there just one cable that goes from the solar panel to the house? Explain a little bit more on the power system side, why that's necessary.
Yeah, absolutely. I think the simplest way to explain it is, the biggest challenge with power is always going to be getting it from where it's produced to where it's used, right? And so I think, that if you're not familiar with the power industry, the common conception might be, like you said, oh, why wouldn't you just hook something up? You've got solar panels on your roof, for instance, right? And that is an example of how it can work in that way. But realistically, when you're talking about large quantities of power, the goal is to transmit them from where they're produced to where they're needed. And to do that, you have to change your voltage level. So when we start talking about power transformers, that's really I'll say the key component for power transmission, because without those devices, changing from what we would say is like a low voltage level for generation, going to step up that voltage to something that we would use for transmission. So when you start talking about, I don't need to get too technical here, but when you start talking about, high voltage, 230 kV, 138 kV, kilovolts, that's what we would say is like a transmission level voltage versus 600 volt DC or 1000 volt DC. That could be like a solar array voltage. So it really is just about navigating that. And then of course, there's a lot more to it just in terms of, how do you keep the system reliable, right? How do you protect the system? How do you integrate all these different technologies together? So that also comes into it. And that's, where a lot of those power electronics come in and those other devices. But, hopefully that's a decent
very
overview?
helpful. No, very
Okay.
helpful.
Yeah, that's helpful for us. I would. Do you have any follow-up questions on that? Because I would like to talk a little bit about supply chain
Sure.
for a
Yeah,
second.
please go ahead.
At CEO, we talk a lot about domestic manufacturing. You guys obviously have a tremendously necessary product or series of products for our infrastructure here in the United States, our energy grid infrastructure. How would you articulate some of the challenges that we've seen lately, either from the on the development side to make sure that as an industry we're continuing to make sure that the grid works, or if you'd rather talk about on the supply chain side, some of the challenges that you face and the competitive issues that you face here in the U.S. versus where some of these products are coming from outside of the U.S. I'm interested in those two topics.
Sure. So I think what is critical to understand about the supply chain for energy products is that we are competing not with other companies in the United States, but we're competing globally for the same core materials. And so, AWG has a global footprint. We have customers in 60 countries around the world. And so what we have an opportunity to see is how other countries are moving their energy transition along, and at different paces with different levels of investment. And so a lot of the complexity that we find within the world of supply chain as it relates to the US energy electrical grid is not only that there's constraints within manufacturers in the United States, but that countries around the world are proceeding with their energy transition, and we have to compete for the same set of materials.
Can you talk about what those are?
Sure. So on the power equipment side, we're seeing the lead times relative to main power transformers from, I'll say, more of the commonly recognized brands here in the United States being incredibly long. And what AWG has been able to do from a global supply chain perspective is identify key manufacturing partners around the world, provide what we'll describe as like a free consulting service to help them modify and build their equipment compliant to the US codes and standards, and then integrate those products into our supply chain to help our customers achieve their projects on time with tight CODs. So with an example of power transformers and the main power transformers, we're probably in the 8 months to 1 year time range in delivering main power transformers, which is probably about 50% less than some of the domestic options that are available. On the pad mount transformer side, we're seeing the same thing. In the renewable space, we have the position where the electric utilities across the country have lots of pre-existing long supply agreements with the domestic manufacturers, and in times of this huge investment, the project style business within renewables sometimes has the lower priority relative to the grid needs that utilities are required to maintain with the public utility commissions. And so what we find is that the supply chain story is not just a question of competition on materials, but it's also an order of regulation.
Right. That makes a ton of sense.
And I'm curious, I think, we've talked a lot about how the renewable energy industry is in a lot of ways changing many of these systems, like the entire energy system as a whole. Could you speak a little bit to that about sort of like, because renewable energy is distributed and, it operates a little bit differently on the grid, why that might change the demand for these power electronics, these transformers, that type of thing?
I think that there's probably a business, I'll say commercial answer, and then I think there's also a technical component to that, where on the economics of this energy transition, solar is the lowest cost of energy to generate and put onto the grid in the most dispatchable, quickest manner. And it's a technology now that can stand on its own legs. And I think that, we're here at RE+. I think we have record attendance at this show. It's demonstrating the resilience of this industry. And, what I have always come to love and appreciate about this market, and having been in renewables for nearly 2 decades, is that despite the variability of policy, despite the variability of a lot of different factors, this is a community of professionals who are committed to the cause of bringing cost-effective power onto the grid and solving complex challenges in a way that's meaningful for, end users, right? So ultimately, it's not the power bills that we're going to see getting raised because of this complication. So I hope that answers the question from at least the commercial side. From the technical side, there's obviously a level of complexity to integrate these different generation sources. So
Yeah. I mean, I think from a technical perspective, Josh really hit on the key, which is, I think, just the timing of everything, right? And, being able to construct a solar farm. And, there's a lot of talk about, reviving gas plants or even clean coal. And I think, maybe what people don't realize is that those, a gas turbine could be a 5-year lead time. I mean, these are complex devices. Again, they have a lot more, technical power electronics, like internally, that when they're developing these devices, it's a longer process. So, I think with something like solar, again, that timing is key, but also, to Josh's point, there is a concern in some areas, are we, oversaturated with renewables, right? And how do we kind of combat that? So there's always this kind of ongoing, evaluation of grid stability, right? How can we, work with these manufacturers, whether it's, again, inverter manufacturers, substation power transformers, because there are things that we can do working with these manufacturers, kind of, performing analyses up front to, ensure that these renewable resources are going to integrate seamlessly. So there's certainly a lot of challenges that I think come with renewables that, again, I think, we're very prepared in the industry to deal with them. But when you start, again, having supply chain issues, it delays the whole process and can make things difficult.
I just always find it fascinating how, building any power plant of any type of generation source is complicated, and getting all of the timelines to line up is like, an extremely difficult equation to figure out. And so it's cool to talk to, folks like yourselves, American Wire Group, that is doing that and is helping businesses, power producers do that every step of the way, not just for the solar panels themselves or whatever, but then every piece of the power electronics that come through. It's cool.
I think that visibility in the project management of construction within the renewable energy marketplace is one of the key strengths that AWG can provide to our customers, because with our ability to navigate the global supply chain, inventory locations around the country, what we're providing is a predictability and a resilience relative to this industry that gives us the ability to perform and build projects faster than and at lower costs.
On that note, we're at RE+. As you know, numbers are, we're setting new records at RE+ again this year. Let's pivot a little bit to some of what you're here to talk about on the brand and the product side. Talk about what's new at AWG.
Well, first on the brand side, I would like to say that SIA has done an incredible job year over year in supporting the industry. And I think we said there's upwards of 30,000 people that are in registered attendance. And for everybody here at the show listening to the podcast, I would urge them to, if they're not already a member with SIA, to sign up and become a member and show your support for this incredible organization. So thank you guys for all the hard work that you do and for supporting this market. AWG is in this amazing point right now of innovation, where we're seeing key functions to provide resilience across the supply chain with products like we talked about before with our AC cabling called PowerGuard for 35 kV applications, with our DC cabling for 2000 volt applications. But what we're also seeing is a move towards the digitalization of energy. And actually today here at the show, we're so excited to announce the AWG's first step into the digital monitoring world. So I'll let Neal continue because he's much more technically capable to explain that side of the business, and one of the great innovations that we're bringing here to the market.
Like Josh said, one of the new products that we're most interested in, we partnered with a company called Checkness, and they have a smart monitoring device is the kind of the simplest way to describe it. And as Josh said, the key here is that we're trying to look at these operating solar farms and again look at how much renewables has been added to the grid, how much exists in the industry, and empower the end users to be able to run that system as efficiently as possible, document as much information as you can. And again, all of that information ties into benefits to the owner, of course, in terms of reliability, availability of generating plants and whatnot, but of course with the end goal of keeping the power on for consumers, right? And I think getting back to what I was kind of saying with supply chain, I think working with inverter manufacturers, the best way to kind of combat some of the concerns is to really work with the suppliers, on the front end and express, what issues we're seeing in the operating field. And I think that's something that, I was able to help AWG, when I joined is, here's what we're seeing in operations, right? Here are the challenges and here's, what we could do as a solution. And that's basically what Checkness came up with was a smart monitoring solution. It actually takes the string level data, which is basically like the most granular level data available for a PV solar plant, and continuously records that data and sends it back to a central aggregate. We call it a SCADA system or an intelligent network system. So again, the goal there being this is a patented new product, again, first of its kind, where we can kind of say we have this real-time information, for the entire plant. And again, I think there's really incalculable benefits to having that kind of information. And I think, I'm sorry, go ahead.
My tiny little brain doesn't understand what data is it's transferring.
Right. Okay.
Simplify it just a little bit.
Sure. Yeah, of course. So the string level wiring that comes from the PV, the most important characteristic of, I'll say, most electrical circuits is going to be current flow, right? Mm-hmm. So current flow is going to be, typically in a stable range, just representing the maximum output of your panel, your wind turbine, whatever it might be.
Right.
So essentially by monitoring current, you can see, again, if your current's too low, that could represent an underperformance. Mm-hmm. If your current's too high, that could represent an electrical fault, like some kind of physical issue in your system, which again helps you, pinpoint that much more quickly, troubleshoot.
So I think that really what this comes down to is the opportunity for operating plants when they have issues to find the issue quickly, fix the issue, and get the plant back running to its expected performance. Mm-hmm. From the economics of making solar effective, when there's an issue at the string level, as Neal was talking about, there hasn't been a way to do this in a fast and efficient manner until now. And with the Checkness application, what we're able to do is give specific certainty to O&M operators, to developers, to operating plants on saying, hey, this is exactly where your issue is. And once you repair it, the system will indicate that the current flow is back to its correct levels, and the plant it should continue to perform as expected. And
in the end, this makes it easier to operate a grid.
Exactly.
Right? That's the end goal. And the benefit of having that technology on the renewable side, if you try to replicate a scenario where the current flow is down with a fossil fuel generated source of energy, the turnaround time to solve for that challenge is going to be a lot longer than it would be in a renewable energy scenario, right?
Yeah, and it's a scaling question as well, right? So with something like solar, where we would call it maybe distributed generation in the industry, where it's individual panels feeding into inverters and so on and so forth. But, if you have an issue with a main gas turbine, that's probably equivalent to almost a whole wind farm. It could be equivalent to several wind farms depending on where you are. So it's a scaling issue, and it's a troubleshooting, and like Josh said, this has been one of the challenges of solar is troubleshooting, is keeping your systems running as efficiently and as effectively as possible. And when owners were just relying on inverter level data, it was levels of magnitude more time spent troubleshooting. So that's really where this comes in. But yeah, I mean, it all kind of has a chain effect of the faster you can troubleshoot this, and the more energy, that's going to help people with their energy costs, help keep the lights on and everything. So I think it's product we're really excited about.
That's awesome.
It's terrific.
Yeah, and thank you for explaining. Like, there's so much data that when you add additional ways of monitoring these projects, getting more data, that helps not just the operators make better decisions, but the grid operators make better decisions.
Exactly.
And then even, in the future cases, the developers themselves making better decisions about how they build projects and how they get, more energy onto the grid.
Yeah. And flexibility is the key to keeping the lights on in the future on the utility scale side. So I love it. Great job.
Thank you. And, flexibility is built in our DNA, where, we see project schedules shift. We see projects that are building, and, we always kind of tell the story that we'll see customers engage with us when they're at 30% drawings and then 60% drawings. And then they get their IFCs, which are the issued for construction drawings. And then while construction is ongoing, there's always something that happens. And whether it's an expansion on the AC side or the DC side, our inventory and our project management and our power equipment supply chain has the flexibility to weather these changes and make sure that projects are completed on time.
Great. Are there any other messages or products that you guys want to get into?
I think it's really important for us to share a development for an insulated overhead cable product that's fire resistant and really great for safety, which is called Aerial Guard. So Aerial Guard is a distribution product, and distribution means 35 to 15 kV that's used in an overhead application where there may be high risk of trees or fires. And what makes our product unique is that when there's these fire emergencies, other products may catch fire and then drip molten plastic, which is also burning. And our product is different because if it were to be in a condition that it would catch fire, it turns to ash and extinguishes. And so that product, coupled with the entire pole line hardware system, is a solution that we call Aerial Guard. And it's used in both solar, in the home runs on the AC side in many applications, but we also see it very commonly in utility applications. So if you're ever in your car and you're driving by, a tree or a tree-lined area, and you'll see a cable in the air that has a plastic diamond spacer, that's Aerial Guard.
Oh,
So,
cool.
Very cool.
We're looking at different problems across the industry, identifying ways in which that we can bring value by innovating. And this has really been the core to our DNA forever. I mean, when we first launched our PowerGuard product nearly 15 years ago, what we saw in the industry was some need to make the product more robust. And so PowerGuard is 3 times more water resistant than other products that are available for the AC cabling in the market. Our SunGuard product on the DC side is we were the first to bring both the positive and negative phases onto one packaged unit so that it'll be faster to deploy out in the field. So I think that, when we come to the power equipment and cable accessory side of our business, we're taking that same approach of innovation and trying to understand where the problems are, looking not at just the United States, how we've solved problems, but globally, and then bringing that learning back to the US to make us a more competitive and more scalable solution.
I love it. Well, listen, Joshua, Neal from American Wire Group, we're so glad that you spent some time with us today. We're so glad that you are Terawatt members of the Solar Energy Industries Association. And we're so glad to have your leadership on our board, Joshua. It makes such a huge difference.
I really believe in the power of SIA. AWG as a company, our slogan is empowering a better world. And that's what I feel like we do as a team every day. Would love to have you guys come by our booth. We're at booth 8504, and we'll be here through the rest of the week. So thank you again so much for having us. Hope that we could answer and demystify some of the complex component questions that
Very
are here.
much so.
And all of the difficult ones are from my friend Neal here.
Thank you, Neal.
Yeah, thank you so much for having us. This was a great opportunity, and very, very nice to have this conversation.